Hello, class. Congratulations on being done with Chapter 2. Hopefully it wasn't too stressful, but now we're going to start Chapter 3. And this is Chapter 3, Section 1, and it is on identifying pairs of lines and angles. So today we're going to start with the lines. Lines that do not intersect and are coplanar are called parallel lines. If I use this cube, example of parallel lines in this cube could be CD and AB, GH and FE, and lastly CF and AH. Now, there are other lines. For example, BG and AH are parallel, EH and DA are parallel. Okay, so these are only a couple examples, but please remember parallel lines do not intersect, but they are coplanar. Skew lines, which is probably something you've never heard of, are lines that do not intersect and are not coplanar. So they're the opposite of parallel in the aspect that these are not coplanar. So an example of these would be CD over here and BG. So they go in opposite directions, otherwise they'd be parallel, but they do not intersect. Another example would be AH here and FE here. And the last two examples are EH and BG, and then AG, which is the one cutting across here, and EF. So any two lines that they can't be touching, they can't intersect, and they are not in the same plane. The last type of line we're going to talk about today is perpendicular. And two lines are said to be perpendicular if they intersect and form a right angle. Here you can see this box. This is going to be a box, so everything's a right angle. So anywhere these two meet, for example, CD and CB in the corner are 90 degrees. FE down here and EH in the corner, and then lastly AD and AB. So they are the three lines you need to know: parallel, perpendicular, and skew. The next four slides I'm going to talk about are postulates that your book talk about. And all you have to do is just kind of understand this postulate, that if there's a point somewhere in space and then there is a line, that there is exactly one line that is parallel through point P and is parallel to L. So that's it. That there's exactly one line through P parallel to L. If there is a point P somewhere in space and a line, there is one line that is perpendicular through P and perpendicular to L. The last two slides talk about this. If A is perpendicular to C and B is perpendicular to C, then what do you think that tells you about A and B? Yep, that they are parallel. So as long as these are perpendicular to the same line, then they must be parallel to each other. And the last postulate is this, that if A is parallel to B and B is parallel to C, because of cutting out the middleman, B, right here, if we cut him out, guess what? A is parallel to C. Which property is that? Transitive. Good. So that's it. That's all I need you to understand right now about lines and then the four postulates. Thank you.